There are two different ways we can express confidence interval estimates. We can either use the point estimate plus minus margin of error notation. So that would be the first bullet in each of these. There we use point estimate, either x bar to estimate the population mean, or p hat, sample proportion, to estimate the population proportion, and we subtract and add those two numbers. We can look at an example what this looks like. Here's a bell curve showing all the possible samples we could get from a population. Too far to the right, we've got an unusually high estimate because of sampling error. Too far to the left, it's an unusually low estimate. What we do is we shade the middle percentage according to the confidence level. Here we shaded 95% of outcomes surrounding our sample mean, and we're saying our population mean is likely going to be in this range. We've got a confidence of 95% going from this lower limit, or I call it lower bounds, to upper bounds there. And you can see is that we would take a sample mean from the middle and we would add to move to the right, and we would subtract to move to the left, and what we end up with is this interval of numbers. So a first example of how we would do this, here we have a confidence interval for the population mean. We're going to have a point estimate, sample mean, plus minus margin of error. Now we want to change it to this trilinear inequality. We will first subtract the two. This is the lower end of where we think the population mean will be. And then we go and add the two numbers to find the upper limit. And that will be our confidence interval with a certain level of confidence. The other way that we could do these problems is starting with the trilinear inequality and going back to the plus minus notation. So I'll just stick with this problem and see if I can go back to the numbers I started with. Using the formula, for E, we subtract the high minus low and divide by 2. Looking at the picture, we can see why. High minus low is a distance all the way across the mean covering two margins of error, the high side and the low side. So if we subtract that distance and divide by 2, we get each of these segments E. To find the point estimate, we just want the halfway point. Halfway point we add and divide by 2, or basically we average them. So we have subtract and divide by 2, add and divide by 2, just making sure you get the right order of operations. Here was my problem. Starting with the 133.2 and the 425, I'm going to do 1/2 in front times high minus low. And I should get that margin of error, 145.9 there. That's the second number. And if I add them, I get the point estimate of 279.1, which you can see there.